All right, today we're going to talk about technology and how physics kind of fits into that whole process. We're going to start with our objectives. Mostly we're going to focus a lot on light and why that's important in physics. So we're going to describe how the characteristics and behaviors of white light allow us to see colored objects. We are going to describe the connection between physics and technology and describe how the characteristics and behaviors of light are used in technology, like creating any type of digital image. So we're talking cameras, video footage, etc. So just like we usually do before we begin, we'll do kind of a pre-assessment. So pause and answer these questions now, and once you're done writing, go ahead and continue the presentation. Same goes for these two. Go ahead and pause and answer these questions, and then we'll edit as we come to the end of this section. Some terms that are important to know, most of these hopefully you do already know, such as quantitative and qualitative. Quantitative dealing with numbers, qualitative dealing with the quality or more abstract sort of concepts, color, etc. Engineering technology, pixel, RGB, primary color or additive primary colors, subtractive primary colors, rods and cones, which are in your eye. So I would write this down that physics uses math as a language. So if we are to speak plainly about what this mathematical equation means, it means that we would find the speed by taking the distance traveled divided by how long it took us to get there. For example, in your car, you see miles per hour. That would be the miles you traveled over a time, an hour. So what we do is we take physics and it sort of gives us the application of math in the world around us. So math, we use numbers and variables, while physics, our variables actually stand for something. It doesn't mean A and B and C. Instead, we would use things like force. F equals force, M equals mass, A equals acceleration. And then from there, we can plug that into equations and get actual values. So this physics is really just the application of math in the real world and how all of that is actually important and plausible. Physics is one big giant proof. So when we're talking about physics and the laws of physics, we're talking quantitative language. We're talking numbers. We are not talking about qualitative. We're not talking about color. We're not talking about the quality of any of the things that we're studying. Instead, we're looking for hard, fast numbers in physics, which I think actually makes it a little bit easier for us. So then any type of math problem, our textbook is really helpful. You have this little icon on the top of your screen there, and it can take you to see examples of math concepts that are actually applied in physics. So it kind of gives you more context of why we're doing this type of math. Along with science, you guys know what STEM is. You have done some of it before. The E in STEM is for engineering. This is actually taking science and using it to describe or to design products or create inventions that meet our needs as people. So one thing they talk about for the engineering design cycle, they're talking about the wireless smart carts that we will eventually have, hopefully. Basically, you start with a concept, you have a question, you want to fix some type of problem, and then you work through creating something that will help solve that problem. So you begin with a prototype, you test that prototype, you figure out what's wrong with it, you revise it, you go back, you fix your prototype, you test it again, you evaluate it, you revise it, you fix it, you test it, and this cycle goes on until forever, basically, because nothing is ever perfect. So that's why engineering even exists. So we are taking actual science and applying that to designs and products to meet the needs of people. And this creates technologies that we then use, such as cell phones, computers, electricity, you name it, it comes from engineering and creating a solution to a problem. And so we will talk about actually relating physics to the design of technology, how physics goes hand in hand with that engineering component. And using this design cycle, how can we fix any additional problems? Things like cost or energy consumption. Like, think way back when Ford created the car and how that has transformed over time, that cars can drive themselves now. Now that we don't need any gas and we can use battery power instead. So like I said, it's iterative. We are going to continue this until we find the best solution, but we know in physics that, or in science in general, that we just keep going. We keep supporting that. We keep constantly going through this cycle. So technology is everything built in the human constructed world. This is everything. So it can go as far back as the wheel. So we will examine the fundamental physics behind many interesting technologies. So something that we do often, communication. We have to use electromagnetic waves to talk about how we use phones. Displays, we talk about optics and diodes, touch screens, processors, batteries. All of this relates back to physics, and that's kind of how the idea of this course is set up. So we also have these nifty little icons in our chapters that will help us when they come up. So technology will take you to any type of invention or techniques that have been developed in physics. And engineering, which we do have one for this chapter. I don't know if we'll be able to do it because we don't have the things in the sensors, but we'll hopefully be able to come back and finish this engineering, which is actually the design of technology and how we use things. I think for this chapter it's going to be like solar power, if I'm not mistaken. So something that you may be familiar with, taking a picture, maybe not on a digital camera quite like this, but on your phone. How can they do that? How can they read and display all of these colors and the things that we see with our eyes? How is the camera actually able to duplicate that? And digital images trick your brain into seeing a full range of color by only using red, green, and blue, so that RGB. And different amounts of them and mixing them together, you can actually trick your brain into seeing an image. So additive colors is the combinations of RGB when they're put together. You can create lots of different colors. For example, that talks about mixing the red and the green here, you kind of get this yellow color. If you mix the red and the blue, you kind of get this magenta color. Green and blue, you get this like cyan sort of color. And then if we put all of them together, we get white. So this is additive colors are used in technologies to create lots of digital images, your computer screens, digital cameras, computer projectors. That's why if you get like really, really close up to your screen right now, you can kind of see little pixels that are only using red, green, and blue. And your brain actually just interprets it for you. So 1 million or 1 megapixel on an image is 1 million little dots. So whenever you hear megapixel, I believe your cameras will tell you that, and your phones. But that's what it's talking about, how many dots. So the more dots you have, the more your brain is tricked, the more the image seems more and more lifelike. So each pixel is captured by tiny red, green, and blue sensors, and each sensor will record a number from 0 to 255 according to the light intensity. So as you take a picture, it's basically reading every little thing, every little color that it sees and recording it. And think how quickly it takes, how much time it takes to take a picture. None at all, and your phones and your cameras do that so quickly. So 1 megapixel of a digital image is a string of 3 million numbers, which prescribe the intensity of red, green, and blue for each pixel. So we're talking 1 megapixel, which is 1 million pixels, in a digital image, putting together 3 million numbers, and your camera just clicks just like that. So we will be actually doing this interactive. There's a video that goes along with this, and we will do that, I believe, tomorrow. So we're going to experiment a little bit with that RGB coloring. So the investigation will open up the application and then match the first few colors using only values of 0 to 255 for each primary color. And then we'll make magenta, so on and so forth. It'll walk you through this whole process. So I'm going to kind of skip through this part pretty quickly. And then we'll go on to making more complicated colors. How do we make these type of colors? What do you have to mix to kind of create that? So that's what we'll be working on tomorrow. So each of these color wheels are explanations of how colors of light combine to form new colors. So look at all of these as a visual representation and describe how each explains how colors of light combine to create new colors. Critique how well each color wheel explains how colors combine, and based on your experiments and experience, we'll do that as well, and evaluate with these two representations that we have over here, which is more useful to determine the red, green, and blue values to match each color. So you guys may have done this before when you edit things and you try to take a color and apply it somewhere else. For editing purposes, you get this number that's specified. That's really all that you're doing, is specifying those pixels that need to be applied, that are capturing the red, green, and blue within the color wheel. So we use two different methods for creating different colors. Digital devices create colors using emitted light. Print images, so things like books and newspapers, use reflected light. This is a subtractive process. So this is now the other kind of side of doing the subtractive process. So screens display color by emitting light. The pages of book reflect light instead, and then our brains translate that reflected light. So when you view a color page, you have the colors, you are seeing the colors that are being reflected. And which ones, other colors that you're not seeing, are the ones that are being absorbed. So cyan, magenta, and yellow pigments are used in the subtractive process. But like, kind of think back to the other color wheel. If we combine magenta and yellow, now we have that red color. If we mix yellow and blue, we get green. If we mix the cyan and the magenta, we get blue. And then notice that when we mix all of them together, you get black. So this is kind of the opposite of the additive process. So we see here that that's exactly what's happening. The additive process, so our screen, so our light being emitted, the opposite with light being reflected. So where do the colors of the rainbow come from? I'm going to see if I have enough prisms for us to kind of play around with them so we can make rainbows. But basically, white light will enter the prism and dispersed light comes out. And then we see these different wavelengths creating light that we see. Because white light contains all of the colors of the rainbow, which if you don't know Roy G. Biv by now, we better learn it. All of the colors of the rainbow are contained in white light from the sun. Raindrops disperse the white light into colors, and then we can also use a glass prism to disperse white light into its colors as well. So how do we sense color? The sensation of color is the perception of the energy in the light. So once again, we're going back to wavelength. Visible light spectrum only goes from red, and our sensitivity to red at the lower energy to the higher energy violet that we see. So within the visible spectrum, lower energy light appears as red, higher energy light appears as blue, purple, so on. So then our eyes have two different types of sensors, basically. Your rods detect the intensity of a light, while your cones are actually what can detect the color of light and process that back to your brain. Then we have 3 different types of cones, so that light detection. One will detect red light, one detects green, and one detects blue. And then your brain will combine these into an image using color. So digital cameras work just like our eyes. Our eyes have the 3 types of cones that are sensors, versus a digital camera. The pixel then can capture red, green, and blue. So go ahead, we're going to work through these assessment questions here and finish this part up. So explain how you see ordinary non-luminous objects in the classroom. Non-luminous objects in the classroom absorb or reflect particular colors. The colors we see are the ones that are reflected. What type of light is represented on a computer screen by an RGB value? Okay, so the 255, that is the absolute maximum there. That'll be our white light. No light at all would be black. Gray is somewhere in here. Once again, I wouldn't expect you to know this necessarily because we're playing around a little bit with it tomorrow. 255, all the way on the end there would be red, and then kind of a combo of your 255 for red, 0 for green, and 255 for blue would be magenta. List 2 or more technologies that use RGB color display. Hopefully you know that a lot of them will. Your computer screens, your laptops, your digital cameras, your cell phones, basically anything with a screen will use this RGB color display. Describe how the eyes combine colors to see. You have 3 cones, one that detects red, green, or blue, and the brain combines these together to create all different kinds of color. So the next thing that we're going to talk about is science and not any career choice, but most career choices that you may go into or consider, and how that would apply to your life. So basically this is answering, why am I taking this class? So even if you don't plan to go into the field of science, it can still have major implications on your life. So some things that are helpful: using scientific explanation, using empirical evidence, so actual evidence to support all of your claims. How you're able to draw inferences based on data and relate to promotional material for products. We are going to be able to describe the connection between physics and any future career, well, most future careers. And then with physics, because you know you took this class and you knew that it was a weighted class, you know that it's hard. The upside of this and doing this in high school is that it does prepare you really well for future classes that you may take, because we want to support those study skills and help you in your future goals, whether that's a trade school or whether it's college. It's up to you. So assessment, which of the following could be scientific evidence? Go ahead and make your selections now. Pause and start up once you have an answer or answers. Go ahead and pause and think of some answers for these 2 questions as well. And once you're ready, continue the video. We have 2 more physics terms to add to our list here. We have inference and we have testimonial. So, have you ever seen a commercial for a product that seemed too good to be true? I'm sure many of us have. What science can do is it helps our brains be able to process these claims and help us determine if things are factual as they claim. So any good science background can help you in your everyday life. We can evaluate promotional claims for products and services because we're constantly thinking, okay, who is collecting this evidence? Do they have any bias? Are they trying to sell me something? Instead of taking it for the face value. So like if we look here, the snake oil treatment, it says that it is the strongest and best, known for pain and lameness. And then it gives a list of all of these things that it can be used for. But are these product claims reasonable? I see strongest and best while they're advertising this for Clark Stanley snake oil treatment. Okay, I have a lot of questions. How do they know it's the best? How do they know it's the strongest? Have they tested all snake oil treatments? So we can do this by inferring whether the claims are reasonable according to the science that you do know. So having a strong science background and having a lot of background knowledge helps us to make stronger claims against these type of promotional claims that are trying to get us to buy something. So what evidence and logical reasoning could you use to infer whether these snake oil claims are reasonable? As I kind of explained, it says strongest and best, but I don't see any sort of evidence, any type of testing claims, any type of results for testing. So for me, I think that this is not a reasonable statement. So reasonable claims must not be false or misleading in any relevant detail. Reveal relevant facts, including consequences that can result from using the product or service. We've all heard those like pharmaceutical ads where they list all of the side effects that you could possibly get, and sometimes they sound a lot worse than taking the medicine to begin with. And reasonable claims must present information on the benefits and risks of the product in a balanced manner. We're looking for bias here. So testimonials do not count as scientific evidence. That's somebody's opinion, like she's saying, this is the best camera I've ever owned, or physics is the funnest class I've ever taken ever. That is just a personal opinion. Versus scientific evidence saying, well, I have 23% more fun in physics than I do in math. So product pitches often reveal people telling their own stories, why they like the product, but think about what is the weakness of that sort of sales pitch. So critique the company's claim that theirs is the best camera based on her testimonial. Use evidence and logical reasoning for your answer. So right now, go ahead and pause and say why you think that this is a weakness. Use evidence and logical reasoning instead. Any company might be able to find people willing to say positive things about your product. People do anything for money. We see that. We see ads on our social media all the time that you'd think, wow, does that actually work? So for promotional claims to be based on scientific evidence, they have to follow those rules of testing, analysis, research, and independent review in order for us to make scientific claims like that. So when you evaluate services instead of products, you should still apply the same standards of scientific evidence and logical reasoning. What evidence does this company provide to support their contention that using their photo sharing service will make you rich? So this is saying, like, if you use Instagram, you'll become rich. Does that seem logical to you? So a company claimed their fuel cell product could create a substantial increase in gas mileage for cars. The U.S. Federal Trade Commission evaluated this claim and pointed out that there was no scientific evidence to support it. So kind of what this is doing is it assigns an independent review panel. You want somebody who is going to come in and be non-biased about the product or service that you're looking at. So a company claimed they could create energy for free using a device with a rotor and various magnets. An independent panel collected and analyzed data which debunked this claim. So what kind of scientific evidence do you think the panel should collect in order to analyze a claim that energy could be created for free? So some things that also, when you're looking at advertisements that are important, look for fine print. So it says our product will decrease your car's gas mileage by 200%, but you see this little asterisk here and you go down, it says if you also attach a team of horses to tow your car. So is that reasonable? Honestly, if you ever see will increase your gas car mileage by anything that's in a very high number, percentage-wise, it's not going to be a reasonable claim. So there will be some burying of relevant information. So I'm actually going to skip this part right here. So you've all seen a tube of toothpaste. So why learn physics at all? We talked about how science can help us better evaluate the way that we spend our money, the way that we look at the world. It kind of helps us not get tricked. So why learn physics? So a knowledge of physics can help you evaluate questionable promotional claims you face in everyday life. We talked about that. More importantly, physics has applications that are at the core of many jobs and careers, even outside of science. So if you ever wanted to fly a plane or go into the Air Force, pilots must understand and calculate position, velocity, and acceleration of an airplane. A plane can encounter forces that depend on the shape and orientation of its wings and plane's altitude. And related careers, ground repair, air traffic control, piloting drones. All of these things help us or have a backing in physics and help us be better at our jobs. If you wanted to go into optometry, we've already talked about light and optics because that's how your eyes function and how your brain interprets that information. So having a healthy human eye it will act as a lens, and through magnification, aperture, all of those things kind of help, so like the curvature of your eye, help us see. So being able to examine the eyes and diagnose vision problems because of lenses is backed in physics. But you do need specialized medical training in addition to just knowing physics. Electricians, so even trades. Electricians must read and interpret circuit diagrams. That's part of physics. And then use that information to wire electrical circuits. They have to know the difference between series and parallel circuits and how to calculate electrical current. So that way, you don't get shocked or you don't blow a fuse. They also need to know about electronic controls and circuit boards. Hopefully we do a little bit of electricity stuff in our kits that we're going to get. If not, we'll find some stuff to do. So how physics plays a role in careers, you can do research or on the internet. The internet wouldn't exist without physics for a lot of the reasons listed previously. You can talk to somebody in their career field. Not everybody uses physics. I mean, if you're going to be a writer, you're not going to spend a whole lot of time thinking about how your computer works, unless you need to put it back together, I suppose. But in addition to all of those things, physics comes with being able to have good study skills, and they'll help you be successful when you learn physics. And the good thing is that you can apply these skills kind of throughout your entire science career and even further into whatever future career you decide. So taking notes, you want to look and summarize the key points from the things that not only you read, but also that you hear. And we've kind of talked about some ways to do that, some strategies that you can use. And man, it is so great that you can just let your book read to you. At the end of every paragraph or section like this, it does have this little button that will help you if you just want to listen to it read to you. So the way that this book is written that will help you out is you get one idea per page. So it's got some type of page title that is your main idea. And then it's even easier for us because it's outlined. So we know exactly where we're going. So if, for example, we're looking at reaction forces and Newton's first law, there's some subheading here for our outlines. So we can title it Newton's laws and the reaction forces specifically, and the third law. And then from there, each paragraph, we can make even more subheadings to help us kind of organize our thoughts. Drawing pictures in physics is one of the most important things you can do. Not only will it help you with the math portion of things, It helps diagram out what your word problems are saying to you. You do not have to try to do this, but try writing down a one sentence summary for the point each illustration is trying to convey here. Whenever you see a picture, that's just a suggestion. My biggest suggestion to you here in physics is to, when we have word problems, draw a picture. I know whenever I was in college and I was taking physics, our professor gave us points on our word problems just for being able to draw what the word problem was saying. Work cooperatively with your classmates to share what you know. Anytime you have questions, you can ask each other, you can ask me. And then whenever I ask you guys questions and we do discussions, please participate. That's how you learn. And being wrong is totally okay. We've talked about this before. That's why I take some of your grades on completion. It's because it's okay to be wrong. It's not okay to stay wrong. So that goes back to asking for help and getting what you need out of the class. So right now, go ahead. Which of the following could be scientific evidence? Back to your answers, you should have picked A, B, and D. An advertiser claimed that his new machine uses an advanced lever system to output 18% more energy than it takes in. Use logical reasoning to evaluate whether this claim is reasonable. Energy is a conserved process. You can't create energy out of nothing. That's not how it works. That's why we don't have perpetual motion machines. Because whatever you put into it, you are going to get out of it. You're going to get less out of it. Because you do lose some energy along the way. So it is impossible for a machine to put out more energy than it takes in. Think of a career that you are familiar with. Hopefully you pick something you want to do with your life, and then physics concepts that you might need to know. So I talked about aviation, I talked about optometry, engineering fields. Obviously we are talking about applying technology, any type of math. It's good practice for mechanics, electromagnetism, any of the health fields. You have to take a physics and health sort of class in the future. So that is the end of our slideshow, and hopefully you have all of your notes taken. I just want to say that I think I'm going to combine chapters 1 and 2. So there will not be a test immediately following this unit or this chapter. We will be taking one after chapter 2.